In this video series, I will be discussing about diode clippers and diode clampers. So without delaying, let us start with the diode clipper. So what is this diode clipper? So this diode clipper says that, so it is a diode circuit, that means a circuit that consists of the diode. It is a diode circuit. What it does? That clips or it cuts a part of the input. Okay, so that means what I am trying to say here is, if there is a input like this, so if this is the input signal, so it might be voltage or current, and in the output what will happen? So one part of the input will be cut, so that means either we will get a output like this, so second half will be 0, or we will be getting a output which will look like this. Okay, that means one half or one part of the input is cut out, or else it is possible that we can make such an arrangement, we will get a output like this, a portion of the one half also we can get. So without further delay, let us do a simple clipper circuit and understand that how does clipper works. So for that I will be taking one input signal which looks like a square wave. So why I am taking a square wave here is, it will be easy to understand the square wave, and further the concept can be applied to sinusoidal wave as well. So this is my input voltage and this is T, and this here I am taking as the voltage, and we need to pass this signal through a clipper circuit. Now how does the clipper circuit will look like? So we can draw the clipper circuit like just a combination of a diode and a resistor, or we say load resistor as well, and we are measuring the output here. So this is the V0, this is my diode, and here I am applying the input Vi. So how do we analyze that? We have to analyze that in two parts. One is the positive part, okay, and another will be my negative part. So for the both differently we will be analyzing this circuit, what happens in both the parts, then we will be understanding that what is the output and how does this clip a part of the signal. Okay, in this case I will take, this is my 0, this will be your T by 2 and this is your T. That means I am dividing the total waveform into two parts, one is 0 to T by 2 and one is T. So now let us understand what happens if I take for the signal 0 to T by 2. Okay, so in 0 to T by 2, how much potential we have? We have plus B voltage, right? That means the plus part I will consider connected here and the minus part is connected here. In this case, what will happen to the diode? So if this is positive part, so we know that for the diode this is positive and this is negative. In this case I can see here the positive is connected to negative and the negative part is connected to your positive here. In this case the diode will be reverse bias. So what happens when the diode is reverse bias? It will not conduct any kind of current. So that's why that circuit can be replaced with a circuit where the diode can be shown as a open circuited, and here RL will be there and we have to measure the V0 output here, and the input applied here is plus minus and the voltage is V. So this voltage is V. So now in this case we can clearly see that because of the diode is reverse biased and the circuit is a open circuit, in this case no current will be flowing to the output. So what will be my V0 value? In this case the V0 value is equals to 0. Okay, now we will consider for the second part of the wave for T by 2 till T. So if I consider here, so from T by 2 to T, in this time what is the voltage level? Voltage level is minus V. That means my diode will be now reverse forward biased. How? Because in the negative T by 2 to T, so this side will be negative and this side will be positive. Here you can see the negative is connected to negative and the positive is connected to positive here. In this case the diode will be forward bias. So if the diode is forward bias, what will happen? My circuit will be represented diode as a short circuit. So if I do the circuit again here, then this is a short circuit and in this case it was open circuit. So this will be my RL, and the input applied here is, this will be positive, this will be negative, and the value is V, and we have to measure the voltage at this point V0. So V0 is nothing but how much voltage drop across the RL resistance. So if I want to find that, how I can find? So I can just apply a KVL here. So if I apply the KVL here, so plus sign is here, so current will be flowing in this direction first of all. So if I apply KVL now, this is minus, this is plus, so I will take plus B. So if applying KVL across this resistance, so this will be plus, this will be minus, and why I am taking like this? Because the current is flowing in that direction. So minus voltage drop across this RL is nothing but my V0. So I will take minus V0 is equals to 0, and that implies we are getting my V is equals to V volts, positive V volts. So that means in this case the V0 value is V. Now let us try to draw the output signal. How I can draw? So first I will take the input signal and accordingly we will be drawing the output. So which will be Eg. So this is V and this is minus V. So how to draw? I will extend this to line some below, so that it will be Eg for me. Then this is the 0 line, the 0 potential line. So what is happening in the 0 to T by 2? So in this region, so what is happening? We can see here the value of V0 equals to 0. That means, so I will be getting one voltage whose value is 0 for this much of time period. Okay. Now in the second half, in this part what is happening? My output voltage, the value is V. So for T by 2 till T, so till this position, so what will happen? The value will be minus B here, sorry. So this will be minus B. So this voltage, how it will be minus B? Because this voltage, if I take it positive, then according to this voltage is V. But if I take the reference, I am measuring the voltage in plus here and minus here, so that's why you have to take minus B here. Okay. So I am clarifying again. So while putting the KVL, this equation is correct, but while measuring the output voltage, we have taken reference that this is positive, this is negative, but while analyzing or applying the KVL, the positive and negative sign are opposite. That's why the V0 will be minus B, not plus B. Okay. So here it will be minus B. Now we can see here that in the circuit, one part of the signal, that means this part of the signal is clipped out, means for this time the value is 0, and for the other half we are getting a output voltage whose value is same as the input. That means here we have clipped out, so here we have clipped out the positive part, and hence it will be called as a positive clipper. Why positive clipper? Because it is clipping out the positive part. So similarly we can understand what is the negative clipper as well. If it clips out the negative part, then it will be called as a negative clipper. So we will see that through a problem in the next video, that how does that negative clipper will work. Okay. So till then, if you have any doubt, then you can just post a comment, I will try to answer.